All right, our first speaker who's going to sort of set the stage for us is Peter Cegelski from Emory University, who's done decades of work on this interaction between nutrition and TB. And so
anyway, so thank you and good morning, good afternoon, and good evening. Thank you so much for inviting me. Are you seeing the first slide?
Yes, we are, Peter. Go ahead.
Okay, thank you. So, and thank you for inviting me to speak about one of my favorite subjects, undernutrition and the risk of tuberculosis. As Stuart said, it's very timely for updating the data, the evidence on this topic. And I will present to you an updated meta-analysis, updated compared to this study that I'm showing you now, a study that Knut Lonroth and I and colleagues from WHO published in 2010 that demonstrated a very consistent log linear relationship between tuberculosis incidence and body mass index based on the 6 quantitative studies that had been reported by that period of time. And even though the levels of the absolute levels of TB incidence varied across studies, you can see that the slope from all of the studies was quite consistent, such that for every unit change in BMI, TB incidence, the slope of the line was 13.8%. So the TB incidence changed 13.8%, increased for every increased 13.8% for every unit decrease in BMI, and conversely decreased 13.8% for every unit increase in BMI. And please notice that on the vertical axis on the left, that's a log scale, so it's actually an exponential relationship. Now, those 6 studies, if you're familiar with this literature, you'll be quite familiar with these studies. The two of them were the U.S. Navy studies from the mid-20th century, so they included only young white men. Then there was the massive Norwegian study published by Agi Tverdal from the based on mass radiographic screening of the adult population in Norway with follow-up through the TB registry. My study from the early 70s through the 90s based on the NHANES series of surveys and the one NHANES, the first NHANES that was actually converted into a longitudinal follow-up study. There was a study in Finland among male smokers. This was a controlled intervention trial of vitamin E for lung cancer prevention, but they were able to do a secondary analysis looking at TB incidence. And finally, the study from Hong Kong in the beginning of this century, where they examined 42,000 elderly in the National Elderly Health Service, which would be kind of analogous to what we call Medicare in the United States. Not exactly, but similar. In that report, we identified a number of shortcomings, which are now the reason for this updated meta-analysis. First of all, none of those studies included people with HIV infection or children. All of those studies were in high-income countries. 3 of them included only men. Only 2 of them were population-based representative samples, the one from my study from the US based on NHANES, and the Norwegian study based on mass radiography of the population. The Hong Kong Chinese study was population-based among the elderly population in Hong Kong. But keep in mind that those individuals survived the Great Famine in China in the late 50s and early 60s, which was a period of unprecedented TB incidence. So the epidemiology, and they were the highest line in this study. They're this top line up here. So their TB incidence and their TB epidemiology was different from others. And 3 of those studies did not control for confounding at all. Most importantly, for our purposes today, only 2 of those studies had data for people with BMI below 18.5, and those 2 differed tenfold in the incidence rates of tuberculosis. So not only was the evidence in people with low BMI quite sparse, but it was not nearly as consistent as the other studies and as the studies for BMI above 18.5. And you can see them highlighted here. The green one is the my report, and the gray one is the Hong Kong, elderly Hong Kong. And you can see that in this data point, it's not entirely consistent for those below 18.5. So I've reviewed those 6 studies that were reported by Knut Lowenroth in 2010, and I've described the motivation behind this updated meta-analysis. And in the next few minutes, I'm going to focus on new studies of low BMI and TB, first in HIV negative and then in HIV positive populations, and including an individual patient data meta-analysis that was actually focused on vitamin D, but that also examined BMI. And lastly, as I mentioned, I'll talk about the studies in people living with HIV. These are the new studies on low BMI and TB incidence in predominantly HIV negative populations, and I will go through the results in the next slide. I'm showing you this one just to orient you. Since this is an infectious disease modeling group, you will appreciate the first study, Ackley et al. In 2015, where they modeled TB incidence in the First Nations native population of Western Canada. That would be like Northern Alberta, British Columbia, during and after the time that they were relocated to reservations in the late 1800s, which was followed by a severe famine because it disrupted their traditional way of life. Then there was another study from Canada, province-wide in British Columbia, among household contacts of all TB cases during that 10-year period. There were 2 massive studies from Korea. The first one was over 2 million adults covered by the National Health Examination, where they examined not only the effect of low BMI, but the effect of persistently low BMI over several years. I'll talk about that in a moment. There was the well-known study from Peru, originally designed to measure transmission, household transmission, but where they also took advantage of anthropometric indices and serum levels of certain micronutrients to examine the associations between TB incidence and nutritional status. This was a case cohort study. So they had active TB cases and matched controls, followed over time. There was another large study from South Korea, over 11 million adults who participated in the 2010 National Health Screening. And then there was one study that is a case control study, which normally I would exclude case control studies, but in this case, they actually happened to have body mass index measured a year before the diagnosis of TB. So now let's look at the quantitative results of those studies. The first one, the Ackley study from the First Nations populations in Western Canada. This was a fascinating study. They developed 2 models to explain the increase in TB incidence after this relocation and famine. And the 2 models had provided different explanations. In one model, they looked at the effect of crowding together, and they modeled the impact of increased transmission as a result of relocation and crowding. In the second model, they looked at the potential impact of rapid progression after infection. In other words, the first one had to do with crowding, and the second one had to do with essentially the compromised immune system, the effect of the direct effect of the famine on their ability, on the people's ability to contain their TB infection and the risk of rapid progression. And the first model, the one about crowding, did not fit the data, whereas the second model explained the data quite nicely and showed that if you included that term for the increased risk of rapid progression after infection, the adjusted hazard ratio for TB incidence was 5.4 as a consequence of that famine. The second study, also from Canada, showed that among household contacts of TB cases, 33,000 household contacts of TB cases province-wide in British Columbia over a 10-year period, a clinical diagnosis of malnutrition was associated with a 37-fold increased risk of developing tuberculosis during the follow-up period. Now, they didn't quantify undernutrition, they used a clinical diagnosis of malnutrition as their exposure measure. The next study from the Republic of Korea, over 2 million adults, they didn't look at just whether undernutrition or low BMI increased the risk of TB. They looked at the effect of persistently low BMI on the incidence of TB. In other words, if you were undernourished for a longer period of time, did that increase your risk of developing TB more than if you were undernourished for only a shorter period of time? And in fact, that premise was correct. And I show here the incidence per 100,000 population by the years of underweight. In the first, I show the control group where they were not underweight at all, and then just 1 and 4 years of underweight. They looked at 1, 2, 3, and 4 years, but I'm only showing 1 and 4 in the interest of saving space on the slide because it was a linear gradient between them. And indeed, those who were underweight for only 1 year had a 2.2-fold increased hazard of developing TB, whereas those who were underweight for 4 consecutive years had a 3.3-fold increased hazard of developing TB, and the gradient between those two was linear, which is why I'm only showing the first and the last data points. In Peru, they demonstrated that among household contacts with low BMI, the adjusted hazard of developing TB was 4.2-fold higher than those who had a normal BMI. And the next Korean study, 11 million adults who participated in the health screening program at one time in 2010, and then follow up to the National TB Registry. This is the only study that actually has data for degrees of BMI below 18.5. So you can see that those who had a BMI below 16 had the highest hazard ratio, 2.8, of developing TB, and that decreased gradually as the BMI increased towards 18.5. In the last study from Croatia, those who were undernourished a year before TB diagnosis had a 13.6-fold increased adjusted odds of developing tuberculosis during the following year. Then Ibana et al. From Peru, they were looking at vitamin D studies, but they also included BMI in those studies. They collected together individual patient data on 7 different studies of vitamin D that also reported BMI. In the first group up here, we're looking at the entire study population, but I want you to focus on the lower group down here because this is the HIV negative group. I'm going to talk about HIV positive populations in the next slide. So among people who with BMI in the underweight range below 18.5, their adjusted risk ratio for developing tuberculosis was 4-fold higher than those with normal BMI. And just like the other studies that I showed right at the very beginning, people who were overweight had a decreased risk of developing TB. So in this slide, I put all of those studies together. I put the older studies on the left-hand side of the slide vertically, and I put the newer studies on the right-hand side of the slide. And let me orient you to what I've done here. I put the study identifiers here in the outside columns because I wanted to put the measures of effect, the ratio measures of effect, adjacent to each other in the 2 middle columns so that you could compare them directly visually, so that you could compare them directly. I also excluded several studies from the meta-analysis because, well, let me explain why. The Norwegian study, they used a BMI cutoff of 21. It was a beautiful study, but we can't but 21 is a perfectly normal BMI. And so we can't really compare that. We can't really combine that with studies that are focused strictly on underweight. And the same thing with the Finnish study. They used a BMI cutoff of 23, which was their median BMI. So they were looking at above and below the median, but that can't be combined with studies that are focusing on BMI defined as low, under 18.5. Then there was the Western Canada modeling study. I'm excluding because it's a modeling study. It's not a cohort study. And then the last one I'm excluding is the Croatian study, which was reported an adjusted odds ratio as a case control study, which can't directly be combined with the risk ratios and hazard ratios from the others. So in this next slide, I've lined them all up in terms of, in the order of the number of TB cases that were reported in each of those studies. And if you look down the ratio measures of effect, you'll see there's quite a range from a low of 1.7 in the Edwards study to a high of 37.5 in the Moran study, Moran-Mendoza study from from British Columbia, household contacts in British Columbia. So there's quite a range there. And let's put them together into a meta-analysis. I've just duplicated those studies on this slide, but at the bottom, I've added the meta-analysis. On the left-hand side is a simple case down here. At the bottom left is a simple case-weighted average. And I separated the two South Korean studies because they are so much larger than all of the other studies that in terms of a case-weighted average, they would simply overwhelm all of the other studies. So for the two South Korean studies, the case-weighted average was a 2.6-fold increased risk of developing tuberculosis for those with low BMI. And for all of the other studies, the other 7 studies, there was a 7.1-fold increased risk of developing tuberculosis based on having low BMI. So on the bottom right, I'm presenting the results of a random effects model that was developed by Matt Saunders and his colleagues, or our colleagues, from the London School of Hygiene and Tropical Medicine, where we took all of these studies, combined them using proper random effects meta-regression model, and soon to be published, not yet published, where he identified an incidence rate ratio of 4.0 with the confidence intervals that you can see there, 4-fold higher risk of developing tuberculosis for people with BMI under 18.5 compared to those with normal BMI. So now let me move briefly to the studies on undernutrition and TB incidence in people living with HIV infection. There have been 10 new original studies and 1 systematic review and meta-analysis. And in the interest of time, I won't go through all of these individually, but you can see that they are from a very broad geography: Southeast Asia, the Caribbean, and Africa. And in the next slide, you can see others. Again, Southeast Asia and Africa. So for a very broad geography, naturally the countries that have highest incidence and prevalence of HIV infection and consequently of tuberculosis. And in the systematic review and meta-analysis of 43 studies of TB incidence and risk factors for TB in populations with HIV infection, you can see the overall summary risk ratio is 1.8-fold higher risk of TB incidence in those living with HIV infection with low BMI among those living with HIV infection. Now, that might seem initially puzzling that the risk should be lower, or the relative risk should be lower in people living with HIV, since the absolute risk is so much higher of TB in people living with HIV infection. But to me, it actually makes sense, and that's for 3 reasons. One is that a variable number of these individuals were getting antiretroviral treatment. So the risk ratios are going to be heterogeneous on that basis alone. But more importantly, for our purposes, almost all of them were getting cotrimoxazole prophylaxis, which lowers substantially the risk of developing tuberculosis. And many of them, if not most, were also getting isoniazid preventive treatment, specifically to prevent tuberculosis. So that also obviously decreased their risk of developing tuberculosis over the course of the study. So with that, I would like to thank you all for your attention. I will stay on the line for the rest of the session. And if there are any questions at the end, I'd be happy, or now or at the end, I'd be happy to answer them. So I'm going to stop sharing.
Great. Thanks, Peter, for that great talk. Open the floor to any questions from the audience. Yeah.
Hi, Peter. Thank you for the talk. Edward Wenger here. I wanted to ask, it kind of jumps off the page in what you showed, the opportunities of measuring, additional biometric nutritional variables in trials that were designed for other purposes. I wonder if you could speak to places you see opportunities to do that prospectively.
Well, I thank you for that question. And that's not only an important insight, but an important question. So I think that by now we have put, over the last 10 or 20 years, we've put nutrition on the map in terms of epidemiology of TB and risk factor studies, so that any study that's looking at TB incidence should be measuring not at the very least anthropometric risk factors. The data that I presented focused only on body mass index, and I haven't seen a lot of data on others. I don't mean to be self-promoting here, but the one that I published in NHANES also included several other measures of nutritional status. There have been some micronutrient studies, especially the ones from Peru, that showed an increased risk of TB depending on micronutrient status, in particular vitamins A, D, and E, the 3 fat-soluble vitamins. But I think that following directly onto your question, that it is essential that people doing longitudinal studies on TB incidence include nutritional metrics, and not only to evaluate their impact, but also to adjust for their potential impact, adjust between differences between groups in terms of their potential impact on the outcomes that are being measured.
Great.
Did that answer your question?
Edward gave it, so yes. Thanks, Peter. Any other questions from the audience? Great. And yeah, Peter, thanks so much. I know you'll stay on, so if anyone has any questions that come up, please drop in the chat. But yeah, let's thank Peter one more time for that talk.